Hi y'all, today we're gonna do a maximum depth of a binary tree, and for the first solution I'm gonna show you guys a uh, a recursive approach. So the base case is gonna be if it's not the root, or if it's not, basically if it's not a node, we just return 0. Then it's gonna be like this, and we select the max of self dot max depth of root dot left and self dot max depth of root dot right. What this basically does is that it goes through each level and is gonna increase it by 1, right? Then for this, we just go through the left and the right child, and we select which one has the highest depth, and that's how we get our output. And here, let's run it. As you can see, it works. Yep. And for the other approach, we're gonna use the DFS. And for like DFS problems, you want to use a queue. So first, we're gonna initialize our queue like this: q equal dq. And while we have a node, or if we have a node, then we want to append that to our queue, or basically the root, you know. Then we need a variable to store the depth, and we're gonna initialize it with 0. And while we have a queue, or while our queue is not empty, we want to go through the values in our queue. So for I in range of length of queue, and we basically want to get the node of our queue, and we do that by popping, or this is how it's gonna queue dot pop left, like that. And then we want to check if it's the left child, we want to append that to our queue. Q dot pen no dot left, and if it's the right child, then we want to add that child to no dot right, like that. Then so each time we do this, we want to update our depth. So our depth is gonna we're gonna increment it by 1. Then we can just return the max depth, like that. There we go. See, just like that, 2 approaches. And that's why I like doing binary trees. There's like different way of like solving it, and like I don't know, it's just fun to see the different solutions.